My dear students, I am going to read the question. Consider the situation shown in the figure. The diagram is given. Both the pulleys and the string are light and all the surfaces are smooth. A. Find the acceleration of 1 kg block. B. Find the tension in the string attached to the 1 kg block. G is given as a 10 meter per second square. Okay. So now I am going to draw the tensions. So this is an T and this is also T and downwards also T, because one string one tension. So now T plus T, here it is become as an 2T. Understand? So now see here, and downwards the mg will going to act. M is on 1 kg into G, so 1G. So here I am going to draw the free body diagram for the 2 kg block. See here, right side is an tension 2T, this is an 2 kg block. Okay, let's consider the acceleration is towards to the right. Now 1 kg block free body diagram is 1 kg, downwards is an mg, there is an 1 into G, right? So on upwards is an tension T and acceleration is downwards, so I consider as an 2a. Okay, now so 2T is equal to ma, that is an 2 into a. Here acceleration is downwards, so that's why G minus T is equal to 2a. See here, now here is an 2T is there and this side only T is there, so that's why for this equation I multiply with the 2 on both sides. So 2G minus 2T is equal to 4a. Now I placed here, so 2G minus 2T is equal to 4a. Now simply I am going to add here, so 2T will get cancelled, so it's become as an 2G is equal to 6a. So 2 1 ja, 2 3 ja, right? So a is equal to, it's become as an G by 3. Understand? So this is an, now so a1 is equal to 2a2, so that's why a1 is equal to 2G by 3. a2 we got is as an G by 3. Yes or no? Meter per second square. Now we have to find the tension. We'll find the tension. See here, for the free body diagram of 1 kg block, it is an G minus T is equal to 2a. So T is equal to G minus 2a. Now G minus 2a, a is given as an G by 3. So now we find out already. So G minus 2G by 3. So it's become as an 3G minus 2G. So it will become as an G by 3 Newton. So the tension is T is equal to G by 3 Newton. Our option is, first option is an correct answer. Hope you understand that. Okay. Dear students, I am going to read the question. Calculate the acceleration of either blocks and the tension in the string shown in the figure. The diagram is given. Okay. The pulley and the string both are light and all the surfaces are smooth. Okay. So now I am going to draw the tension. So only one string is there, so throughout of the string the tension is T only. Okay. So see here, now I am going to draw the free body diagram of the both the blocks. So first I will take the first block. So this side is an T and mass is an capital M. Now so the equation is comes as an T is equal to ma, F is equal to ma. Yes or no? T is equal to m into a. So if I draw the second free body diagram, see here, for the second block which is hanging vertically downwards, that is an tension is an upward and downwards is an mg. So capital M into G. So here is given as an capital M only. So now acceleration is an, let it be considered the first block acceleration is an towards to the right and second block hanging block acceleration is an downwards. So mg minus T is equal to become as an, it is an ma. Yes or no? So now here I am going to write T is equal to ma, and second equation I am going to write here. So mg minus T is equal to ma. Okay, so simply I am going to add it. So then TT will get cancel. Yes or no? So when I am going to add, TT will get cancelled. So mg is equal to 2ma. So get cancelled. Simply the equation will come as an a is equal to g by 2. So throughout of the blocks, the only one tension is there. So acceleration as a same. So a1 is equal to g by 2 and a2 is also become as an g by 2. Yes or no? So now we are going to be write the tension to find out the tension. So I am going to find out the tension for the first block. So T is equal to ma. So T is equal to m into a. A is came as an g by 2. Yes or no? So total tension is become as an T is equal to mg by 2. Yes or no? How much, my dears? T is equal to mg by 2. Okay. So now if you see the options, our first option is the correct answer. Hope you understand that. Okay. My dear students, I am going to read the question. Find the mass capital M so that it remains at rest in the adjacent figure. Both the pulley and the string are light and friction is absent everywhere. G is equal to 10 meter per second square. Options are given: 4.8 kg, 2.4 kg, 1.2 kg, 0.6 kg. Okay. So now let I am going to be draw the diagram here. So it is given as an 3 kg, this is an 2 kg and it is an capital M. Now the tensions are T on the both side. So now T plus T is become as an 2T. Now M block side is also 2T. Yes or no? Now tension on the both the sides. Which side? Capital M and 2T side. So the tension on both the side should be equal. Which are those sides, my dear? Capital M block side and 2 blocks which is hanging side, both are equal. So now free body diagram I am going to draw for the 2 blocks which is hanging in the downwards. So one is an 3 kg is given, another is an 2 kg is given. Now tension is both the sides is an T only because it's only one string. Upward is an 2T. Now so if I find out the A net is equal to F net upon M net. Yes or no? So F net is equal to how much, my dear? So A net is equal to, so 30 minus 20. Yes or no? Are you getting my point? So this side is an 30, that is 3G minus 2G upon 3 plus 2 is equal to 5. Now A net is equal to 10 by 2, that is 30 minus 20 is equal to 10, 10 by 5. 10 by 5 is equal to 2 meter per second square. So A net acceleration is came as an 2 meter per second square for the hanging blocks. Now I am going to be find out the tension. Okay, for see here downwards is an 20. So for 2G block, so now tension is an upward direction. Okay, now acceleration is also upward direction. So the equation is comes as an T minus 20 is equal to 2 into A. Now T is equal to 2 into A. A is came as an 2, so 2 to the 4 plus 20. So T is become as an 24 Newton. So if the T is equal to 24 Newton, then 2T is equal to how much, my dear, from the capital M block side? So 2T is become as an 24 into 2, it is an 48 Newton. So 48 Newton for the capital M block side. So I am going to draw the capital M block free body diagram. So upward is an 2T, so downward is an mg. Yes or no? So equation become as an 2T is equal to mg. Yes or no? So because it is an equilibrium, so no acceleration. So 2T is equal to mg. So 2T is equal to 48, that is equal to m into 10. So now m is equal to 48 by 10, that is equal to 4.8 kg. Are you getting my point? So capital M is become as an 4.8 kg. Our first option is an correct option. Hope you understand, students. My dear students, I am going to read the question. Determine the constraint equation which related the accelerations of your bodies A, B and C. Okay. So see here, I am going to be mark the tensions in a given diagram. So here is an T. So this is only one string. So total throughout of the string become as an T. Now T plus T is become as an 2T for the down string. So here also it's become 2T. So now for the last block 2T, see here this side is also 2T. So 2T plus 2T become as an 4T. Yes or no? See here. So this is the total one string. So T plus T it's become as a 2T. So this total string is become as a 2T, only one string. So now down is an 4T. Now if I write the acceleration related that, so I am taking as an AC block, it is AC. So 4T is become as an 4AB. So 2T is become as an 2AB. So now I am going to write the constraint equation. So 2AA plus 4AB plus AC is become as an 0. Okay, that is the constraint equations. If you want to how to write the constraint equations, see my video lectures. Okay, so now the first option is an correct option. Hope you understand that. My dear students, I am going to read the question. If block A has the velocity of 0.6 meter per second to the right, determine the velocity of the cylinder B which is hanging vertically downwards. Okay, see now I am going to be draw the tensions. Okay, so this is an T, here also it is an T, this is also it is an T, because one string one tension. So throughout of the string is an T. So here T plus T it's become as an T plus T plus T, it's become as an 3T. Yes or no? So now I consider the 3T acceleration A, then T acceleration become as an 3A. Yes or no? Velocities V and this side is an 3V. Yes or no? Now the according to the constraint we can able to write is as an VA is equal to, it's already given 0.6 meter per second. Then now VB is become as an 3 times of VA. Yes or no? So now VB is equal to 3 into 0.6, that is become as an 1.8 meter per second. So this is the velocity of B block. Okay, that is an cylinder. Which direction, my dear? Downward direction. See here, if it is coming right side, then cylinder B cylinder will comes downwards. Okay, so direction is downwards direction. So VB is equal to 1.8 meter per second, downward direction. So our correct option is, the first option is an correct option. Hope you understand, students. My dear students, I am going to read the question. For the pulley system shown in the figure, each of the cable at A and B is given a velocity of 2 meter per second in the direction of the arrows. Determine the upward velocity V of the load M is. Options are given: 1.5 meter per second upward, 2.5 meter per second upward, 3.0 meter per second upward, 5.0 meter per second upward direction. Okay, so now I am going to be draw the free body diagram of this pulley system. Okay, see here now. So I am going to draw the FBD diagram for this pulley. See here, now this is the pulley. Okay, now here it is a constraint one side and another side is an pull with the 2 meter per second. So constraint side is an velocity is 0. Now velocity of the pulley, the formula we know that Vp is equal to Va plus Vb upon 2. So Vp is equal to Va, how much, my dear? 2 meter per second plus 0. Yes or no? It is an constraint. So by 2, that is equal to 1 meter per second. Yes or no? Now I am going to draw the FBD for this pulley system. Okay. See here now. See, this is a pulley. Now the string is in upward direction and another string in second upward direction. It is become as an 1 meter per second. We already find out. So this is given in the question. It is an 2 meter per second. Now the direction of the pulley is an upward direction. So Vp is equal to, we know that 2 plus 1 upon 2 is equal to 3 by 2. So Vp is equal to, it comes as an become a 1.5 meter per second. So this Vp pulley velocity, only the velocity of the block which is hanging downwards to the pulley. So our first option is correct option. So 1.5 meter per second upward direction. Hope you understand, students. My dear students, I am going to read the question. The force exerted by the string on the pulley is, okay. So now we have to find out the force on pulley. So I am going to draw the tensions. So one string, one tension, so TT. Okay. So first we have to find out the tension in a string. Okay, how much the tension in a string, then we can find out the net tension. So now first I am going to find out the tension in a string. Okay, for that what I have to do, I have to find out the A net. A net is equal to F net by M net, my dears, we know very well. Yes or no? How much the F net? So F net is an 60, yes or no, 60 upon 2 blocks is an 10. So 0 0 get cancelled, it's become as an 6 meter per second square. So A net is equal to 6 meter per second square. Yes or no? I am going to be find out the tension for the 4 kg block. So because it is an very easy to find out. So this is an acceleration. So now tension T is equal to 4 into A. Yes or no? MA. That is an 4 into A. So 4 into 6. 6 we already find out here. So 6 4 ja 24. So tension is came as an 24 Newton. Now I am going to draw the free body diagram of a pulley. Okay. So now, so downwards is an tension T and backward is an tension T. Now we have to find out the net tension by the vector addition. Okay. So it is an 90 degrees perpendicular to each other. So now T net is equal to root of T square plus T square. Okay. Now it's become as an root of 2T square. Now if your T square will take common, so it will become as an root 2T. So that is root 2, T value we already found out, that is an 24 Newton. So my dears, T net is become as an 24 root 2 Newton. So this is our answer. So in the options, okay, the second option is an, see here, the second option is an correct answer. Okay, hope you understand, students. My dear students, I am going to read the question. Two men of unequal masses hold on to the two sections of a light rope passing over a smooth light pulley. Which of the following are not possible? Options are given. The lighter man is stationary while the heavier man sliding with some acceleration. 2. The heavier man is stationary while the lighter man climbing up with some acceleration. 3. The two men are sliding with the same acceleration in the same direction. 4. The two men moving with the acceleration of a same magnitude in the opposite direction. So here, my dear students, this is a completely, it is a conceptual understanding question. Okay, so we have, so here the third option is not possible. Okay, it is a conceptual understanding. Okay, third option is given as an the two men sliding with the same acceleration in the same direction, because the man's masses are different, right? So that's why first two option is an possible. The lighter man is stationary while the heavier man sliding with the some acceleration. In the same manner, second one is also possible. The heavier man is stationary while the lighter can climb with the some acceleration. So third one is not at all possible because the two men sliding with the same acceleration in the same direction, it is not possible because they have the different masses. So fourth one is also possible. The two men moving with the some acceleration of the same magnitude in opposite direction. Yes, it is possible. So our correct option is third option is an correct option. That only is not possible. Okay, hope you understand, students.